All right, guys, today we're looking at section 12.2. And so in the past, we found areas of polygons. So chapter 11, we got really good at finding the areas of polygons. Today, we're going to take a look at surface area and lateral area of prisms and of cylinders. And we've done this before way back, like in chapter 1. But we're going to refresh our memory, and I'm going to kind of break it down step by step for how you should do it here, okay? So a prism, if you recall, is a three-dimensional figure where the bases are congruent and parallel. So it could be triangular, it could be hexagonal, etc. A lateral face is one of the faces that isn't one of those congruent bases. So they're always rectangles in a prism, okay? Lateral edge is one of those edges on those rectangles. A base edge is one of the edges of the congruent bases. Altitude is just another way to talk about height. They say altitude because you could have a prism that's oblique, so it could be laying on its side like this a little bit, and the height then would be that straight down distance, but it's really the same as the height, okay? Lateral area then is the area of that distance around the outside, all those rectangles. An axis, if you're dealing with a cylinder, and I've made it oblique like this, that axis is what's joining the two circular bases. Composite solid, we'll get to later. That's more made up of shapes that, maybe like a silo, or just you got a cylinder with a hemisphere on the top kind of a thing. Okay, so the idea here, lateral face of a prism, the bases here are clearly those two triangles, and the lateral faces are the rectangles going around the side. In your notes, you need to have a place for prism, cylinder, pyramid, and cone, and eventually sphere. And you have to be able to calculate surface area and volume of each. So you got to have formulas, and I'll break it down for how you should figure it out. Okay, so the lateral area, or the area of those rectangles, is the perimeter of the base times the height. So you need to have in your notes somewhere that P is the perimeter of the base. Okay? If you don't have that down, later on you're going to look at it and you're going to forget what the capital P represents. And H, the height, is the distance between the two bases. So it's not always up and down. It could be side to side, however far apart the bases are. So make sure that you have that written down. So pH. Okay, so the lateral area of the regular hexagonal prism. Okay, we know that our formula is capital P, or perimeter of the base. Because it's a regular hexagon, each base edge is 5, and there's 6 of them. So that's a total perimeter of 30. Okay, so capital P is 30. The height here is that 12. That's the distance between the two hexagons. Okay, 30 times 12, 360. All right, why don't you guys try one? So they want the lateral area. Okay, lateral area is P times H. So we're going to calculate them separately and then bring it back in. So capital P is the perimeter of the base. Each base edge is 3 centimeters long. It's an octagon, so there's 8 of those. Okay, so capital P is 24. The height of the prism, or the distance between the two octagons, is 9. So when I get up to here for lateral area, I'm going to go the perimeter of the base times the height. And when you take 24 times 9, you get 216. Okay? All right, the total surface area. Well, I've got the lateral area taken care of. I need to add the bases on there. So this pH, that was your lateral area, plus 2 times capital B. Again, you have to have somewhere written down in your notes that B is the area of the base. And from chapter 11, we should be able to calculate it. If it's a triangle, half base times height. If it's a rectangle, base times height. If it's a parallelogram, base times height. If it's a regular polygon, half the apothem times the perimeter. So you got to recognize what shape you're dealing with first before you move on. pH plus 2b. So find the surface area. Because you have a rectangular prism here, you could determine any of the faces could be the bases. Let's just let the front here and the back be the bases. I would always identify what you want that to be. So when I talk about capital B, that's going to be the area of this 6 by 6, in this case a square. When I talk about the perimeter, or capital P, it's going to be 6 plus 6 plus 6 plus 6. The height here is the distance between the two squares, which is 12. Then I could just plug it into the formula, okay? So pH plus 2b, okay? P was 24 because we had a square that had 6 on a side, 6 times 4. The height was 12, that was the distance between the two squares. Capital B was 36, 6 times 6. Well, now I just need to put all this in the calculator and work it out, 360, okay? Why don't you guys give it a shot? I'll start putting the formula up on the board. So surface area here is pH plus 2b, okay? Before you get going, we have to recognize that those two triangles are my bases, okay? So perimeter of the base. We've got a little bit of work to do here, you guys. I know that this is 12, but what's this? Okay? They drop down, and I'm gonna erase this for a second just so we have something to look at. They drop down that 8 as a height, and it looks like it's dividing into two equal parts. They don't say it's isosceles, but I think we have to assume it here. So this is 6. If you use the Pythagorean theorem, 6 squared plus 8 squared is 100, so this side would have to be 10. And that makes my perimeter 12 plus 10 plus 10, or 32. Okay? The height, the distance between the two triangles, is 10. The area of the triangle, half base times height, 1/2 times 12 times 8, which is 48. Okay? That being said, surface area, capital P, which we said was 32, times H, which we said was 10, plus 2 times the area of the base, 48, okay? So 320 plus 96 is 416. So I would break down each of these pieces first before you start plugging them into your calculator, okay? All right, so a cylinder is basically a prism, except we don't have, you know, polygons for faces. But it's the same idea, right? You've got congruent bases, which are circles in this case. So when I say pH plus 2b, well, the perimeter of the base is the circumference. That's 2 pi r times the height. So 2 pi r h is that lateral area. And then your bases, circles, have an area of pi r squared, so there's 2 of those. So 2 pi r h plus 2 pi r squared, okay? So the first question, find the lateral area and the surface area of the cylinder. Okay, so lateral area, 2 pi r h, r is 14, h is 18. When I go to find the entire surface area, I've got to go plus 2 pi r squared. Well, again, r is just 14. So I've got everything I need to know here. Lateral area, r is going to be 14, h is going to be 18. There we go, 1583.4. Okay, surface area, I already know both those variables, so I just need to add in the 2 pi and then the 14 squared to get my area. Okay, so let's do one on our own here. So lateral is 2 pi r h. Okay, the radius there is 12 and the height is 20. So I'm just going to type these in. 2 times pi times 12 times 20. And I'm going to get about 1507.96. So that's going to be my lateral. Okay, 1508, I guess. So it looks like one of these top two. And my surface area is that lateral area, which I already found, plus 2 pi r squared. Okay? So in my calculator, I'm just going to add 2 times pi times 12 squared. Now I get 2412 here, 0.74 in my calculator. So it looks like A is our answer. Just identifying the radius and the height, and then you can plug it all right into your calculator, okay? All right, a soup can is covered with a label shown. What is the radius of the soup can? Okay, so if you think about that label, you're gonna wrap that label around the soup can. It's gonna be your lateral area, okay? So lateral area is 2 pi RH, okay? And I know the height is gonna be this 8. So when I wrap it around, it's still gonna be 8 inches, but I really don't know what the radius of that soup can is. That 15.7 is like the circumference there. That doesn't help me out a ton, but I do know the height. So what is the lateral area though? Well, I've just got a rectangle here. I can take 15.7 times 8 to actually find the lateral area. Okay, and that's what they're doing over here, 15.7 times 8. That's that 125.6. Okay, so 2 pi r h, h was 8. The only unknown now is r, so I can just divide by 16 pi. Okay, and I get about 2.5 for my radius. Okay, so let's have you do 1. Find the diameter of the base of a cylinder if the surface area is 480 pi and the height is 8. Okay, so again, surface area is 2 pi RH plus 2 pi r squared. And we're going to put in what we can put in. So I know the surface area is 480 pi equals 2 pi r. I know the height is 8 plus 2 pi r squared. Okay? So I'm ultimately going to be trying to find r here. Okay, so I've got 480 pi equals 8 times 2, 16 pi r plus 2 pi r squared. All three of those terms have a pi in them, so I'm going to divide by pi. And then what I have left is a quadratic. It's kind of gross, but that's what I have to work with. So I'm going to get 0 on one side. I'm going to have 2r squared plus 16r plus 480. I'm going to factor out a 2. Okay, and then I'm going to try and factor this here. So I need to find numbers that multiply to 240 and add up to 8. Well, that doesn't work out so good, does it? Well, let's see what we've got here. So 240 divided by, oh, it's going to be minus this. I'm sorry, you guys, minus. So multiply to 240, subtract 8. So 24 and 10, that's close. 24 minus 10 is 14. 240 divided by 12 maybe. 12 and 20, there it is. Okay, so 20 and 12. I need a positive 8, so positive negative. So initially I think r could be negative 20, but that doesn't make any sense in context. So r has to be 12. Now, if r is 12, it's asking me for the diameter. So I double it and I get 24 inches for my diameter. So I did need to do a little bit of math, a little bit of algebra there to work through that quadratic, but there we are. Okay? There's your assignment, page 850, 9 to 31 odds. Make sure you write the formulas down, identify the bases, and then find the unknowns. Good luck, you guys.